This lesson is about the basic skills that we need for graphing. I'm going to show us a few steps in terms of drawing a good graph and doing it through an example. So why do we do graphs? Think about the reason why we want to do a good graph. Scientists use graphs all the time to communicate their data in a visual way, so that when someone looks at their graph, they know exactly what the result is and what the implications of the result means. ICA, the relationship of the graph, which means it is very important that our graphs are clear, they are large enough for us to see, and they are accurate. So for example, let's say that we are going to do your graph. So that is a relationship between your length of the pendulum and its period. So your independent variable would be your independent variable will be your length, and then your dependent variable being your t, your period, which I'm going to write as this over here. Let's take a look at going through each step, and then I'm going to draw it on here on the graph below. Number 1, in terms of clarity, we must have an underlined descriptive title for a graph. I'm going to write the relationship between a pendulum's period and its length. So that's going to be my descriptive title. I'm going to underline my title. So notice it's not just, period versus length. That doesn't tell us anything about the graph. So making sure your title is a bit more detailed than that. Step number 2 is to make sure your X and Y axes are properly labeled, and most importantly, making sure they have their units. Sometimes a variable is applicable. In our case, you will find that a variable will be applicable. What does that look like? Well, our x-axis is going to contain the length of our pendulum that we vary. So here we want to write length. And our variable we are going to use is L. So you can use L as your variable. And this will be in units of meters. I know you had it in centimeters. When you do your actual graph, you want to make sure it is in meters, for reasons we will talk about later. As for our y, you looked at the period. You looked at the period, and our little sign for period looks like this, and this one is measured in seconds. Okay? So we did our descriptive title, we labeled our axes properly. Sometimes in your lab reports or and even scientific journals, their graphs, all their images, their figures, every single visual has a bit of a caption underneath. So for our case, if you ever do a formal lab report, your Word document software might allow you to write a caption, and so this might look like graph number 1, and then this is where you give a little description about your graph and what your graph is used for. What is it trying to show? That's a little caption underneath. You want your graph to be very large. It should take up about 2/3 of your page, if not more. In our page right here, our graph takes about a little bit less than 2/3 of the page. I would even make this graph a little bit bigger if you had your graph paper, so maybe even look like making sure it's taking up even this much of the space if possible. But for our case, we're going to leave it as is. The most important thing that I find that people make mistake is choosing our intervals. When and where do we start from? The most important thing is making sure that your intervals are consistent, which means if you taking a look at every single gradient, if you choose every single box being, say, for example, 10 centimeters, so that being 0, 10, 20, 30, etc., make sure that you're not changing it up and going from 0 to 10 to 15 to 30 to 45, etc. Making sure every single box increment is consistent. The interval is consistent. There's a little trick in terms of determining what your graph should look like and how your graph would be scaled. Let's take a look at an example. Many of us have this problem, have this trouble. Let's say our data for our graph in terms of our time data, and I would take a look at your data. I will look at what is the largest value of your time data and what is the smallest value of your time data. I'm going to take an example. Let's say from my time data, I saw 155 seconds was the largest, and then my smallest time data was 0.98 seconds. A way to help me graph this out is I like to choose my very bottom of my graph, something smaller than my lowest value, and the top of my graph something a little bit higher than my value. But in this case, this is 1.55 seconds, so that might be fine. We might just go all the way, use all the way at the top, and that may be okay. Now, your scale does not have to start from 0. That depends on what your data set looks like. Maybe it is all clustered around a value. So that means that when you want to represent your graph, if you want to show a relationship, you might have to zoom in, quote unquote, zoom into your graph so that your scale reflects that. Of course, if you do that, you would need to make sure that your scale is labeled properly. In our case, if I'm doing 0.98 seconds, I might make the bottom of my graph 0.95 seconds, which means this guy down here being 0.95 seconds, and then all the way to 1.55 seconds. How do I determine how to break all of this up? I determine that by looking at the difference between 0.95 and 1.55. So I look at this, the difference between this is 0.6 seconds. I count how many increments I have up to the top. I know this is 20 increments, which means if I want to divide this up evenly, I will take 0.6 seconds divided by my 20 increments. This means that every single increment will be 0.03 seconds. That means the next one up would be 0.98. Then this one will be 1.01. The next one will be 1.04, 1.07, and etc. Okay, so here's are some of the techniques that I use to help us break our graphs down, to help us use as much of the graph as possible to show your relationship. Okay, but don't forget, the most important thing to take out of this is that your graph, the function of a graph is to visually communicate information, which means it needs to be clear, large, and accurate. So as long as you follow these three principles, hopefully intuitively, you'll be following some of the rules that we talked about before. You will need to use some of these skills to do your graph of the length of your pendulum and its period. And we'll tune in next time to the next video. Thanks for watching. Bye now.